Seminar, the quarter. We're going to try something a little different today, which is a bit of a call and response. We've been spending the whole quarter this term talking about modeling and explaining to a lay audience what models are, what they do, how we use them, where the direction of the field is going. And so to wrap up this today, we've invited two speakers. One is Beth Wemple from Cambridge Systematics to talk about a vision for sustainable transportation and where she thinks that we need to be pushing policies into the future. And then we'll have a bit of a response from Keith Lawton, who is used to be the, what did you used to be? You're a transport modeling consultant, but you've worked in Metro in developing some of the modeling tools that we have been using and are still using today, to talk about where the field of modeling is going to go to respond to some of these policy questions. So before I introduce them, I want to talk a little bit about what you who are enrolled in this class need to do to wrap up your term. So on Tuesday, by 5 p.m., you're supposed to turn in your written assignment to me if you're registered for this class as a civil engineering student, and to Jennifer Dill if you're registered as a planning student. So don't mess that up or you'll be penalized. All right. So the way this is going to work today, Beth's going to talk for about 20 minutes or so, and then Keith's going to respond, and then they're going to have a little discussion amongst themselves if they like, but then we're going to open it up to our usual questions from the audience. So just to introduce them, so Beth Wemple is a senior associate at Cambridge Systematics, and she's well known and respected in the field of safety. And she's worked in road safety research and transportation policy and planning. She was the project manager for the National Cooperative Highway Research Program to develop the first edition of the AASHTO Highway Safety Manual. And then Keith Lawton is a transport modeling consultant and the past director of technical services in the Metro Planning Department here in Portland. He has been active in model development for over 40 years. So a wealth of knowledge in both of these speakers today, and I'm going to turn it over to them.
All right, thanks. Well, I'm not Keith. I'm Beth Wemple, and it's probably obvious, or I hope it's obvious anyway. So I'm going to talk to you today from the practitioner's perspective. I'm not a modeler. I don't claim to be one, but I can talk to you. And I can use your outputs and try and figure out how to use modeling outputs in the work that I do. So in good form for presentations, I'm going to tell you what I'm going to tell you, and then I'm going to tell you, and then I'll tell you. So what I'm going to talk to you about is how modeling is evolving to a need for to support multi-criteria decision-making. What are cities thinking about today? What are the challenges they're facing? What are some of the trends in analysis here in the state? And then how modeling is going to be challenged, I think, by where we're headed. So why I'm talking is I've been doing this for a long time, 20-ish years. And I usually am working for public agencies, usually doing long-range transportation plans, so helping them area-wide figure out what their transportation needs should be in the future. Sub-areas, areas, and I've done it here, lots here in Oregon, but also Alaska and Louisiana, Utah, around the country. I'm also on the ODOT STIP Stakeholder Committee, and that committee is essentially a technical advisory committee to the least cost planning project that CH2M Hill is doing a great job on. So I'm sitting there providing my input from the safety perspective, but also thinking about it in terms of practical application. When push comes to shove and we want to do this, how would my typical client be able to do this? So what's unique for me is I don't have to provide answers. As a consultant, you usually have to provide answers. And thankfully, I just get to raise questions today, which is just a relief, especially in this subject area. So first off, what are cities and counties thinking about right now? They're thinking about, first of all, resources are constrained. We don't have any money. We can't keep building. What should we build? What's the right thing to build right now? And if I want to grow into something in the future, what are the performance characteristics of what I want to grow into, and how do I get there? What would be the right things to invest in right now? So they're thinking about all this in the context of pedestrians, bicycles, roadway safety, thankfully, is becoming more and more prominent. active transportation, how does transportation help obesity, livability, sustainability, congestion, traffic flow reliability, you name it. What did I not say? I didn't say mobility. Mobility, thankfully, in my opinion, has dropped down to not be the dominant decision factor, but it's now another decision factor. And I think that's great. The challenge is now we have a whole bunch of decision factors, and how do we, as FHWA pushes us toward more and more quantitative analysis, how do we do that for more and more performance measures, pedestrian and bicycle accessibility, health, emissions, traffic reliability, delay? So all of this also is then being done in the context of communities want economic growth, they want to provide the right kind of housing, they want to protect the environment. So it's quite a challenge to be a transportation planner trying to achieve quantitative results and balance all these needs for your community. So least cost planning is one of the tools that has bubbled up as a resource to figure out what's the right thing to do right now. And performance measurement has bubbled up as something that tells us if we want to look like this and measure that performance, how would we build to that? So least cost planning, folks have heard about it, not heard about it? Some? So something that, and I think Keith is going to talk about it a little bit more too, it was legislatively required in 2009, I think, that Oregon start doing this in the transportation planning realm. And fundamentally what it boils down to is several categories of indicators about what your community wants to be like. And then within those categories of indicators, there's performance measures. And that help you say, well, if we're performing like this, that indicator is good, bad, or ugly. And a community can then weight those categories of indicators to say, you know, for us, energy consumption is more important than for you who really care about journey ambiance, however you say that word. And so a community for any given transportation project or series of transportation, bundle of transportation projects, they would do all this quantitative analysis to say for each performance measure how we're doing, and then they could weight across those categories to come up with essentially a cost-effective decision. All these performance measures are monetized, and then you get to a benefit-cost analysis in high-level summary. So where we're headed is categories of indicators. I think there's 9 categories. So it's environmental stewardship, accessibility, land use and growth management, quality of life, mobility, funding, economic vitality, safety and security, equity. And then within each one of those, that's 9, within each one of those, there's several performance measures. And this is great, right? Because now we can really start a dialogue about, when we see solutions come up, we can start a dialogue that says, well, if we do this, it has this cost-benefit analysis, it has this impact to our greenhouse gases, it has that impact to safety. And people can have a more educated or more informed conversation about the trade-offs between alternatives, because you've converted them all to the same common denominator. So that's great. The challenge is that now we're really pushing what we need from models. So we'll need almost all of these indicators. I went through it the other night, and almost all of the 9 have 2 or 3 performance measures. And all of those 2 or 3 performance measures, almost all of them rely on a travel demand model as either the only input or outputs from the model that go into other models, economic models or land use models. So we're pushing what we need from models, and we're pushing communities that may or may not have the modeling expertise that's here in the Portland region to need more and more modeling resources. It's going to become a challenge for us. Another element of it is that some of the performance measures that are in there, safety, we don't necessarily know how to do it yet. We don't necessarily know how to predict the best way or a good way to predict safety at a planning level, to say if it's this land use or this transportation network, we'll see more crashes in this area than we would in that area, and here are the financial implications of that. Same thing, there's one of the performance measures in I think it's quality of life, really is journey ambiance. And I mean, I actually think that's great. But how are we going to measure it, and how are we going to agree to that kind of a performance measure? I think it's a real challenge, and I think modeling, sort of remembering that so much of this is predicted off of modeling, and then you're having this community dialogue is a real challenge. Let's see. So least cost planning is going to help us do the right thing right now, because we'll say, for this array of transportation alternatives, we think we need the most cost-effective decision based on our community values is whatever it is. You know, an additional lane or these bike paths or whatever it is. We've decided this is the most cost-effective thing. The challenge is, another challenge is, in the future, if we know what do we want our community to look like? How do we want our transportation system to perform? And how do we know what the right thing is to build in the future? So we have the right thing right now, I think, with least cost planning, but what's the right thing that we want to grow into from a performance perspective? And if you think about all the performance measures that we've developed through the least cost planning, or CH2M Hill has developed through the least cost planning process, and then you start to think of, well, how do I want my transportation system to perform? I want it to be sustainable. I want, many of these same things. You're going to have to predict that performance into the future and agree to how it should be for our community. And again, we're going to be relying on travel demand models to do a lot of this work. So hopefully, in my quick run through my conversation, you've seen that we're going to be relying on travel demand models quite a bit to help define what our communities look like. And we're moving beyond traffic volume outputs and vehicle miles traveled and vehicle kilometers traveled to these real challenging questions of, well, how many crashes would it be? What happens if I change my policy from X to Y? Where would people want to live? It's a more challenging set of questions. And in a time when we have less money and we want jobs to grow, it's a real challenge to balance all this. Thankfully, we have Keith to tell us about how the models are really going to perform, because I think it's a big challenge for us looking to the future. So.
Okay. Well, I don't know much about safety, so.
Actually, we're just going to give you the microphone so we can hear you online.
Don't I have a microphone?
Oh, you do? Oh, I'm sorry.
Yeah.
Go right ahead.
It says it's on. Okay. So I'm going to really be talking about modeling in general. I'm going to try to do two things, one of which is to kind of bring into perspective some of the things that you've heard. You've seen a lot of detail about various models and dealt with land use models, more than one kind, activity-based models, and that kind of thing. So I want to kind of talk about that. I also want to talk about some kind of evolving philosophy that I have, at least, or at least opinion. And now that I don't work for anybody, I can say what I feel and be pretty bluntly honest on occasion. Also, I'm old enough to do that. So we talked a little bit about least cost planning. It's an idea that was actually borrowed from the electrical supply industry. And the best example, obviously, would be the business of saying, well, rather than build more power stations, why don't we insulate houses? So this is like something that has nothing to do with power generation or power distribution. It's something else. When we begin to think about applying that in a planning sense, it gets to be very large and very complex. We don't just provide power. We're actually looking at different ways of achieving some of our objectives. It could be a land use method. It could be something that has to do with health and nothing to do at all directly with transportation. So we have a lot of different goals and a lot of different ways of getting at them. And what we're trying to do is to achieve our goals or achieve our picture of the world at the least possible cost. And we have a lot of things coming down that are external that make everything move around. It's going to make life a little difficult for us. So I just want to go through the toolkit. This is kind of a background, and you've done some of this. But one of the most important things I'd like to get to you is that we can't do it with one model. People talk about the model, the metro model, the MPO model, whichever. We really need multiple scales, tremendous amount of detail for pedestrians, less for automobiles, etc. Large scales, how do we interact cities, how do we interact across the state and across a bigger region. And there are multiple points of view. So I'll just start off with one that I think is underneath an important one if we want to pay attention to economics, and that is an economic forecasting model. And that normally lies at the front end of pretty much everything we do. Typically deals with economic regions. An economic region is an area that works as an economic entity or unity. Could be Washington, Oregon, and Idaho, I don't know, but it's big. It certainly isn't just Portland Metro, but it could be the big metropolitan area. It certainly isn't the state. The state is not an economic unit at all. It's kind of got boundaries all over the place that don't work well. So an economic forecasting model is typically a driver, and then it can be linked to economic forecasts or estimates for states or MPOs. Okay? And inside of Metroscope, for example, at Metro, there is an economic forecasting model. Inside of SWIM2, which is a statewide model, under what is now PCOS, there is an economic forecasting model. So that's there. The state, on the other hand, with its official forecasts, doesn't use official population forecasts that are supposed to be used in planning. Doesn't actually use an economic forecasting model. It just does cohort survival. And it doesn't really work well in my mind, but it's easy. The next thing is that's really important are integrated land use and travel models, where we look at land use and transportation together and how they feed back and forth to and from each other. Typically, all land use models, you've already covered some of this, are path-based, which means we don't go 20 years into the future, but we go a year at a time. Because people make decisions each year in terms of investment or in terms of development that are then done. Next year, that thing that you did last year is done. Whether you underfilled a zone, whether you did full density, did less density, that's in the past. And so you're actually building out into the future over time. So path-based thinking is important. There's also an element of probability in the sense that when developers, as you go forward, developers go, should I locate my stuff out there in Hillsborough? Or should I locate it in Beaverton? Or bigger still, if you're looking at Intel, where would I put my next big plant? I mean, next big cloud plant. Is it going to be Austin, or is it going to be in Portland? And if it's in Portland, is it going to be in Hillsborough? Well, it's in Hillsborough. But that's like a roll of the dice. That makes land use forecasting models very, very difficult to deal with, very difficult to calibrate, because there's a probabilistic element in that path. These models can be tightly or loosely linked. They can be equilibration models. Metroscope used to equilibrate, probably still does. SWIM2 does, or the PCOS models do, or not. UrbanSim does not equilibrate at each step or each year, each piece of the path. It's a moving kind of, trying to move towards equilibration. And Luster, which is land use system design in R model, I think, developed by Brian Greger, is the ultimate in terms of a non-equilibrium model. It's really designed to create a lot of different future scenarios using the stochastic path choice to have developers make different decisions probabilistically in terms of where they go. And for a smaller city, that's pretty important. A small city area like Medford or Bend, those things move fairly rapidly. The decision to put this development there can really change the way the city operates. Mm-hmm. In a big place like Metro, there's a lot of stuff there already, so these decisions are not as impactful. So these models can also be used to create a single likely future which is traditional in all of our planning. And it comes from the 50s and the 60s. We have this long-range plan. We have a fixed land use one way or another. And we plan for that likely future. Well, the military doesn't do that. They don't go into a skirmish or a war saying, here's my plan. They look at a lot of scenarios and say, gee, what happens if? And those scenarios are qualitatively based, they're modeled, and they pay a lot of attention to that. We don't do that at the moment. But so we can develop a range of futures based on path probabilities. Toolkit continued. That's two parts of the toolkit. The detailed traditional travel models have been trip-based, moving to activity-based tours. The static network loading, static assignment, is moving to dynamic network loading. And this is typically what is thought of as an MPO model. It can be used to estimate travel demand, network behavior, given a socioeconomic and detailed land use scenario or forecast. And I'm going to come back to this a little bit, because to me, the forecasting takes place here and here. These are really forecasting efforts. And the detailed traditional model is really a way of taking a forecast and evaluating it. You can take the present and evaluate it, change some policy issues, and look at the policy impacts. It's not purely a forecasting model, in my opinion. So it's built from past data. Okay, we go out and we do a survey. We've done lots of them, household surveys. But by the time we develop the model, that's past. And I'll talk a little bit more about that as we go on. And it has limitations. The most important limitation, in my opinion, is data ranges, particularly fuel prices and the cost of operating an automobile. We've not paid any attention to it over all of our modeling. And I started modeling in 1966. Okay, it's 46 years ago. It's been the cost of fuel and has been so constant and so little varied that it hasn't been a really big issue. People pretend that we have price of fuel in the models, but right now, most of the models in this country, in fact, do not, for some technical reasons. What the model can't do is reflect changing user values, attitudes, or preferences. And so it can't deal with the things that we dealt with, in a way, with waste, solid waste, where we got people to recycle. That changed attitudes. That was education, information, propaganda, whatever. But what we do when we use the models the way we do traditionally is we say, none of that changes. People just do what they did yesterday. Yes, they age, and yes, the households change, but basically nothing much else changes. And that might be important. The other problem that we have when we have these detailed traditional models and the two previous ones we talked about, these are big, heavy, slow models. It's very, very hard to look at a whole range of scenarios. You had a presentation, I think, by Brian Greger on green step. And that's an example of a model that's really designed to look at a lot of scenarios very quickly. And that's what I call a strategic model. Some people call them sketch models, but I think that's doing them an injustice. They can be run quickly to look at a wide range in scenarios, or to develop scenarios in a consistent and transparent manner. And the land use model that also Brian Greger built does exactly that. You can build land use forecasts very, very quickly. He built a whole lot for the Medford area. He built 60 land use forecasts running through this fairly fast model. And it turned out that the way of looking at the transportation system that they were planning was to see how robust was it under all of these futures. Okay, risk analysis. Well, it turned out that the same transportation plan was great for about 60 to 70% of the scenarios. There were a couple of scenarios that were really way out, like would be way more expensive to fix, would need new facilities, And so you use the models in a different sense. You start thinking about, oh, I found out what I don't want. How do I stop it from happening? So that's now getting into the middle of policy. So it's kind of useful. And I think we actually need to spend quite a lot of time or effort developing more and more of these strategic models which enable us to look very quickly, particularly at land use alternatives. Right now, looking at land use alternatives is a fairly slow process. It might be possible to introduce something called system dynamics models. And the oldest example I can think of is Forrester's Dynamo, which was used in the limits to growth studies. There were a whole lot of software available. And I can't remember his name, but you've got a guy in system sciences here that is very, very good with SD models. So it's something that most transportation modelers don't know about or don't think about, but it's an important way of, and possibly an important way to go forward. So what do good travel models give us? They give us a good understanding of how the system works, primarily from the perspective of the user or the resident. So we can tell how people react to changes in density, changes in the supply of transportation, how the system reacts to changes in the mix of people as people age and as households change, etc. And so we get a very good sense of how all of these transportation linkages work in terms of travel behavior. The person who does the modeling or the model development gains a lot of insight. So I would think a person like myself or like Joel, we've done quite a bit of this. We can kind of look at a policy and say, that's going to be really hard to do. Or look at something and say, yeah, the models will probably back us up on that. So in other words, we get some knowledge, some internal knowledge, just from working with the data. So it can be used to explore policy and investment options in the short term. You just don't bother with forecasting. Look at what happens if we change some of these variables in the short term. Look at what the elasticities might be from our models. And we can use it to evaluate forecasts or scenarios of land use and economics. So that's pretty straightforward. I have actually seen the phrase in terms of going out for an RFP for a model of having an evidence-based point out is that's evidence of the past, and there is no evidence of the future. And all I kind of think about at this point is we need to be aware of what it is we're doing and to think about what we've really got. Oh, no. So I can't say anything nasty about FTA?
No, this can go down there. But then the mic right there.
It's a different mic. Different shape.
Put it on your shirt. It's going to work better. And you turn. Oh.
Sorry, everybody. So we have no evidence about the future, just some estimates. So what do good travel models not give us? They don't give us a forecast that is without caveats, okay? So we need to be aware of what those caveats are. Something that has not been kind of thought about in the work at the state is some of the possible externalities, possible game changes. Fuel prices are, to me, the most important. We're moving into a new future. I think it's fairly obvious to us as India and China and others move forward that the competition for fuel is high and going to get worse, get higher. I'm not sure it's worse. So we don't have a very good way of looking at fuel prices, in part because our history only has a very narrow range of fuel price. What happens when it's 10 bucks? What happens when it's 15 bucks? How does that affect car buying, which is a slow process? It takes time to get rid of cars, time to change over the fleet. How does it affect travel decisions? And what people do now is they say, oh, I'll just use the elasticities I have off the current model. Well, I can promise you they're about as good as guessing. They're not, the elasticity is very, very low, and we don't really know what will happen. Financing. As we move to more and more higher cost fuels, we're going to move more and more towards more fuel-efficient vehicles. It's already happening. It's already a problem. We're going to get PHEVs, plug-in hydroelectric vehicles, where some of the fuel comes off the electric grid. That's very inexpensive. We're going to see more use of natural gas, and we're going to see less diesel and less gasoline. Well, the money we get right now is from gas price, right, from gas taxes. And that's going away. So we're going to have to look at financing. It is going to be much more than it's just happening to us. We've got to think about how do we deal with it, and I'll talk a bit about that. The world and the US economies are moving around. Is that going to have an effect on the way people travel? And when you talk about least cost planning, do I want to invest in something assuming nothing changes when some of these things may make those investments worthless? So thinking about them is pretty important. And lastly, kind of strangely, birth and death rates. We typically kind of say, well, the past is the way it's going. And I kind of watch television and read the newspaper and suddenly see that we've got 25 or more % of teenagers type 2 diabetes. What does that mean in terms of death rates? How would that change the cohort survival? Should we be thinking about it? As the structure and the age of the household has a lot to do with travel, but also has a lot to do with pretty much everything. So these four things are things that people don't think about a lot, but they are possible game changers and are worth thinking about. So what I'm trying to do is just open people up and say, it isn't just a focus on the models, because we modelers do that, and we kind of believe them and we live in them, but we need to kind of step back and look at where we're going. Some of the modeling issues: bicycle, pedestrian, improved transit. Basically granularity, and models to improve that granularity are already in place or being put in place in San Diego, LA, Sacramento, Seattle, where they're using parcel-based or microzones or blocks or block faces as the storage point for the data for travel rather than the TAZ. You still use the TAZ for some parts of the modeling, but for a lot of the modeling, particularly for pedestrian and bicycle, we need much more granularity. And people are coming up with this method of having more than one scale to the network, more than one scale to their models in a consistent model. So it's happening, and we're well along the way. Equity analysis, very well handled by activity-based models. We have the list of how people travel. It's very, very easy to look at who's hurt and who's harmed and who's helped by any one of our policies or our investments or what have you. It's a very easy way to look at the old trip-based model based on matrices is very, very weak in terms of equity analysis. But we have ABMs coming in, and if you really want to look at these things, they're essential. I want to talk a little bit about accessibility measures. They're internally important in activity-based models. How accessible things are to you. How many things can I get to in a reasonable amount of time by car, by bike, by walking, by transit, have a lot to do with how you chain your trips. People who have poor accessibility make fewer tours and many more stops in the chain. And these accessibility measures are direct in ABM models, and they're getting more and more used, and people are becoming more aware. They're also important in land use forecasting models. Accessibility to households from the point of view of businesses, accessibility to businesses and jobs, that kind of thing, places to shop, whatever, from the part of householders or homes. Has a lot to do with the quality of life. We've talked about quality of life, but accessibility can be used to measure how good your accessibility is to a lot of different things. An example, kind of a roundabout example, would be if you think about New York, particularly Manhattan, mobility is pretty bad. Everything's very slow. You can't afford to even park your car. And yet, their accessibility is fabulous. They've got thousands of destinations they can get to with very slow modes, walking, their transit system, etc. And so what you are really thinking about there is, how can I live my life? What's close? And this really gets to the core of least cost planning, which has to do with how do you arrange land use. And we did this when we did the Western Bypass, which is before any of you were here. We looked at the west. There was a Western Bypass around Portland area proposed, and we looked at land use alternatives. In other words, if we change the land use, do we still need the bypass? And the answer was no. And it kind of died on the vine as a part of that. There's a measure called Hansen accessibility, which is more quantitative, which is really the sum at the bottom of a destination choice model, or the sum at the bottom of a gravity model. Hansen originally did it with a gravity model in the early 50s. And in the US, people have used a variation on that in terms of accessibility, thinking about the log sum, the log of the sum, the denominator of a destination choice model or a gravity model. We use destination choice models. But there are some reasons why a straightforward Hansen accessibility might make more sense. And all that does is simply say, as I get further and further away in time from where I am, I value those attractors less and less and less. So that's pretty straightforward. And how do we do that? Well, combination of all streets networks, not the usual MPO-style network now, but all streets, geographic information systems, modeling packages. Transit makes it more complicated because transit is dependent on schedules and waiting times and walking times, so you can't just skim it off a GIS. You've got to go in and think about, how do I find my way through a network which has headways, etc. Transit microsimulation is being developed in conjunction with Dynasty, University of Arizona. That's a SHARP-2 project C10, which is putting together a whole model for Sacramento, which has full microsimulation of the network, as well as an ABM. So from my point of view, the most important set of performance measures are accessibility measures. If I had my way, I might even think about doing all the modeling based on accessibility. It's pretty important. Environmental measures, air toxics, traditional emissions, straightforward. Models are there. Greenhouse gas, somewhat straightforward. EPA's MOVES has some problems. Doesn't really think about well-to-wheels, doesn't think too much about vehicle mix, but probably can be overcome with some effort. MPOs, in terms of their models, have a boundary problem. So, and it would be particularly true for an MPO that has other MPOs nearby, and that is their householders make journeys beyond their modeling boundary. Typically, we don't count them in any of our analysis. We say, oh, we only care about. We drive everything off a set of models that was built for infrastructure and building roads, etc. But it's pretty important to think about the totality. I mean, greenhouse gas has no boundary. It's a worldwide phenomenon, and we basically have to figure out within the state how to deal with that in a consistent manner. That's coordination with a statewide model, etc. Active transportation and health, another thing that's been mentioned. Intuitively straightforward. With our models, we can show that people walk more, with certain situations of the models do a great job. But I was on a committee for a TRB, Transportation Research Board Institute of Medicine study, and we had lots of doctors and very smart people there. And we found we couldn't deal with it, not very easily, nor the modeling people from the universities either. So we've got an issue of self-selection and preference. So some people who like to keep fit or like to exercise look for a place where they can do that as part of their daily life. They can walk to work, they can live in the Pearl if they can afford it, etc. But there's a bunch of other people who say, well, that's not my lifestyle, but I got a gym in the basement, or I'm going to go work out, okay? And so to know where we are with that, we need to do much more thinking in terms of how do we look at all of the exercise? Do we need special purpose surveys? How would we think about that? So just looking at it from a transportation point of view is not quite as simple as it first seems. Financing, and I mentioned this, not just something that's happening to us. I would say that various forms of road pricing are in our future, which means we need to model those. And we pretty well know how to do that. ABM models with better network models will enable us to do that. Politically difficult, but if we actually want to have the user pay to some extent for transportation, we're actually going to have to go this route. So activity-based models, again, are important. In fact, I don't think you can do it without them. So I've covered this. What are we missing? Information on short-term, on response to very high fuel prices. One of the thoughts that we've been having is to pay much more attention to the surveys, particularly the latest survey we have, which we haven't used yet, and start looking at how do households budget, how do we get information from other sources, okay, to find out how much spare money out. So, for example, we have a household income. Well, if you've got $25,000 a year and it's one person, or $25,000 a year and it's 6 people, those are very different budgets. And they have very different ways of trying to deal with that. How do I just trade off within my transport budget, or do I trade off against housing and trade off against food and clothing? These are the things that we don't do right now, but we might need to go to as we go forward. And as I've said before, an expanded suite of fast strategic models for developing scenario variations and thinking about alternative futures and looking for robust solutions. Well, another approach to model use and planning, just as a thought, is to start from a desired future and use the models to figure out if you can get there, and if you can, how would you get there? So that's kind of thinking about using the models the other way around. I've got some things I desire. What do I know from my understanding of land use interactions, travel behavior, developer behavior, all the rest of that would help me get to where I want to go? And I didn't know I was going to have these metro people here, and I put remember the road to Damascus. And well, as you know, in the land use plan the metro put together about the time I was leaving, 2004, I think, 5, somewhere in there, we decided, or Metro decided, that it would be desirable to have expansion and growth in the areas of poorer farmland. Think Damascus, right? East side. And all the development has been on the good farmland, and the pressure is on the good farmland in Washington County. So the models were essentially run, and guys can correct me, with some constraints, which simply said, there's no land there, here's the land. Well, the model's going to go, well, there's the land, I'm going to put it there. But there's a reality in the modelers were kind of looking at this and talking to the policy guys too, and saying, you know, we should look at this. Maybe this isn't going to happen very easily. Because if we ran the model, say, without some of those constraints, it would show us how hard it might be to make things go to Damascus. How much more accessibility do we need? How do we need to change the transportation system in such a way that it connects with the rest of the region in a good way, more completely, and particularly to the west side? everything like that. So models can be used to kind of further policy directions, but you've got to use them rather than saying, well, no, we don't necessarily want to think about that. So my last word is think.
Challenge to ask more of our transportation system. So it's not just mobility. We're asking our transportation system and our plans to consider a full complement of things that we want. So health, safety, economy, sustainability, quality of life. And as we look, some countries are even holding the bar so high to think about our happiness. Right? So I don't think our travel demand models are capable of dealing with that performance measure just yet. But we are at least asking at a minimum that our citizens be satisfied with the things that we do and satisfied over the collective range of things that they would like to accomplish in their daily lives. What we hear from Keith is, well, we've got a lot of work to do. And so on one hand, that challenge is very exciting to us in the room who are starting to engage in these activities from an academic standpoint, and for those practitioners in the room who are dealing with it on a day-to-day basis. So before we open this up to questions, I'd like to know if you two have anything to say directly to it.
Makes me think of Saturday Night Live.
Yeah.
Jane, you.
Oh, yeah.
It feels far more formal. Well, I took a lot of notes and have a lot of questions, and you kind of touched on one of them. So this is really cool stuff and exciting to think about. But like for your Joe average transportation plan, I mean, it sounds like you did some of this, or Brian did some of this in Medford, but just some community somewhere. How much of this is happening, if anything, and how do people move there? You know what I mean?
Well, it's kind of...
So how much of this is cutting edge, and how much of this is, yeah.
Well, ABM is moving out of cutting edge into kind of regular use. The work that Brian has done, he's an unusual guy. He thinks outside the box all the time. And I work with him some. I'm supposed to help him, but actually he bounces ideas off me, and I spend most of my time going, oh, that hurts, right?
Yeah.
But when he came up with that with Luster, and came up with this way of developing a range of forecasts for Medford, the interesting thing is that when he went down there and presented it to the commissioners and the planning commissions, etc., they were much less scornful of that than of a single forecast. They said, we understand how this happens. The future isn't fixed, etc.
Yeah, I mean,
and so they resonated, which was interesting to me. I didn't think they would.
It makes sense to me that, I mean, one of the things we always joke about is the one thing we know about the model is that it's always wrong, right?
Yeah.
And I mean, I'll usually say when I'm presenting something, outputs from a model, and it says there's going to be so many thousand vehicles here a day in 20 years, I try to tell people, look, we're not expecting that number of cars. We're expecting something in that range, and we're looking for decisions that influence one lane of the freeway or 2 lanes on the arterial, but we're not trying to expect so many vehicles per day. And so it kind of resonates with me that it would make sense to Medford.
Yeah, the key to all of this is the interaction between land use and transportation.
Yeah.
You put in transportation, you get more sprawled land use. You put in less, and it gets a little tighter. So.
Right. Yeah.
So it makes sense.
Yeah.
And we are living in a region that made a decision in 1975, I think, or 76, I think it's still there, to complete I-205, to not widen or build any new radial freeways, and not to widen them beyond 6 lanes.
Yeah.
And that's had a huge impact.
And it's extremely unique. I mean, I know you know, and probably most in the room know, it's extremely unique. I mean, when I work in other communities around the country, and I say, well, in Portland, and sometimes they're really interested, and sometimes they roll their eyes like, oh, that's a different country, and we can't do that here.
Yeah, but the jobs moved out to Washington County where the people were, and the people moved there.
Yeah.
Changed the balance.
Yeah. Yeah.
So let's open up and invite all of you to join in this conversation. So anybody have comments or questions? Remember to use your mic.
I was curious, it seems like government's response to transportation is that it's always a response. They're never leading the market. You know, they wait until the highway demand requires then an additional lane, or we wait until population density reaches a certain threshold to add bicycle lanes or transit. I was wondering if you guys had any thoughts on actually government leading the market and saying, you know, like your last slide mentioned about building a transportation system that we want and letting the market respond to that as opposed to the way it is now.
Yeah, I think you see glimmers of it in things like streetcar. A lot of cities around the country, you know, saw the success of our streetcar. Are saying, I want one of those, even if we may not have the right kind of environment for it. Let's build one and see what happens. And you're seeing that. So I think you see glimmers of it, but sort of wholesale, not yet. I don't know if you have a different opinion.
Oh, in a way, though, what we've been doing all along is getting into this forecasting business or trying to see where we're going in terms, and the land use is the driver. I mean, this drives pretty much everything. And we've been doing long-range plans for as long as I can remember, which is quite a long time. Actually, the remembrance isn't getting as good anymore. I don't remember as far back. But essentially, government does take a somewhat proactive kind of look at this. They don't always do the things that you want them to do, but there has been planning, certainly here. The decision in '75 not to build more freeways was based on a realization that it wasn't going to get us out of trouble. You know, an early decision was to build 205. But those were all decisions that were a long time in the making, along with the Columbia River crossing.
So I noticed in both the presentations, least cost planning is kind of a theme or thematic whereby, if I understand it correctly, you consider several factors, both direct and indirect, in evaluating whether a decision is going to be worthwhile, and you choose the one that has the least cost to it. But when you're talking about models and you're going to be using all these different type of models, some of them are very cutting edge and some of them are less cutting edge. But if you're going to add up all those models together, it's going to be a large portion of the analysis. I mean, what would be the argument to justify the cost of all that when the ratio of the evaluation might outweigh the outcome of it?
Well, the cost of modeling is a lot less than the cost of building.
True.
Just for starters. And I think the best simple example was the one I kind of gave, which was looking at forecasts for Washington County and the way they had been laid out and largely not modeled. Coming up with a push to build the Western Bypass outside of 217, way outside, from I-5, and some people wanted to go all the way to I-5, in other words, cross the Columbia again. That turned out to be politically, as you might expect, not easy to do. But we also then, with 1,000 Friends pushing, looked at what are essentially less cost alternatives. If we change the way we think about the land use, we still have the same number of households, and we weren't smart enough to think about accessibility, can we achieve a solution for people to be able to get around, do their business, without building that, but by changing land use? And that turned out to be a positive direction. Did we fully analyze the costs and the indirect costs? No. And that's what we need to learn to do.
There's evidence that younger people are driving less than their older counterparts. Have either of you seen any agencies, or it's a two-part question, have you seen any agencies that are doing a good job incorporating that evidence into their models, and which models do a particularly good job of responding rapidly to new information?
Rapidly. So what we're really talking about there is fairly straightforwardly a choice to own fewer vehicles. And that would be the most obvious place to come into the model. Right now, we don't have kind of a trend yet, but we're beginning to see it happen. We do know that people's values have changed, that the young people are going, I'm much more interested in the internet than I am in a new car, or any car. And I'm not even bothering to get a driver's license. So this is definitely a change in attitude. And you could look at that in several ways. If you don't have any information at all, you could run scenarios which look at how might that affect those younger people as they come through in terms of their car buying. You might want to change some of the constants in a car ownership model and see what does it mean. So that's kind of one way of looking at a scenario. But you also want to look at any surveys, any information you can get, any interviews, talking to people, talking to futurists, thinking about what would that mean and how could I bring that into my models. And if it came into my models, how would that change my decisions? That's my response anyway.
Well, it seems to me that we're only collecting our transportation data once a decade, right?
Yes,
and so
yes.
it seems like there's a huge opportunity here with the wealth of, there's lots of discussion about, what are we going to do with big data? That people are collecting data about us all the time. We're giving them lots of information about our behaviors. But it seems like the traditional modeling framework and even the new modeling framework, when we talk about activity-based models, aren't really responding to this wealth of information that we're getting about technological change, about attitude change, about behavioral change. And so how might we be able to rein in some of this information that certainly corporations are using to understand how to predict our behavior, at least on the near term? So how do we participate in this?
You're the professor.
I want the application of it.
No, seriously, I mean, using secondary information smartly, and another example would be Brian Greger when he was looking at developer behavior in smaller towns. How many houses did they build at a time? What are they looking at in terms of accessibility? So he was using purely secondary data, nothing from a base survey, to come up with a set of rules which dealt with accessibility, dealt with the number, the size of a development, the distribution of the size of the development, we draw from the distribution, etc. Some very simple approaches to say, I can kind of back into that in a reasonable manner. So it doesn't have to be evidence, it doesn't have to be like totally evidence-based because we can't collect enough evidence. The other smaller side is, some people in Metro will remember that I pushed right until I left to stop doing one survey once every 5 or 10 years and just do a continual survey of households, much smaller.
I think back there. You just have to hold it. You have to keep holding it. What?
Anyway, I'll talk about this.
We need you to talk.
I'm Paul Menig, Tech IM. I just recently left Daimler Trucks, where I spent a good part of my career developing trucks. And talking about thinking outside the box and different things coming, a whole bunch of things jump at me as game changers, and I'm wondering how freight figures into these modeling for people. So we have the Panama Canal, which I've talked to a number of people, is going to have a tremendous impact on this state and what's going on. We've already seen some of our shipyards closing. Natural gas infrastructure is being talked about for trucks. They're going to put in at truck stops across the United States so that we have the ability to do a tractor going with natural gas across the U.S. Over the last 3 years, we put in urea infrastructure to help with emissions, a new fluid that had to be available everywhere in the United States. We have CAFE regulations, and one trucking company just demonstrated a tractor that can get 9.3 miles per gallon over the highway versus the typical 7.2. Some people want dedicated truck lanes. Offshoring, anytime manufacturing moves off-site of the United States, there's less trucking that has to be done. Yet my wife buys just about everything over the internet, and so we have a UPS truck. I know the driver. He's there every day. And then there's also the FedEx guy and coming into my my subdivision and stuff. So one of the things I'm involved in is looking at what do trucks have to do and look like in 2030 for the trucking industry. So tell me a little bit, if you can, about how these models take into account the movement of freight.
Okay.
All you.
Thanks. Not very well. Essentially, we're pretty good at long-distance freight because we have data from the what's it called? Goods movement, commodity flows, commodity flow data that is collected by the feds on occasion. This sample keeps on getting smaller, and we've got where it's reasonably easy to put together long-distance truck models. We've got them well integrated with SWIM, which is the statewide model. Metro has one pretty well integrated, including transfer stations. That has to do with big trucks. The thing that we don't know a lot about is UPS and all the rest of them, the guys that do the deliveries. They do them in tours. There's been work done in Alberta, Canada, that is beginning to move us towards those models. But we are almost data-free. We can't get trucking companies to tell us very much. From another angle, though, working on Green Step with Brian Greger, we basically came to the conclusion that we could probably fix greenhouse gas with cars, but trucks then become the majority. So you start thinking about, well, what do I do with trucks? Clearly, natural gas would help because it's less carbon for the amount of power that you get. What else can we do? And we don't quite know. But all of this issue of offshore, of what comes through the ports, etc., is something that's not very well handled right now. And a lot of people are looking at it. There's a growing group of people who have gone, well, maybe the money will be there and I can get a job.
I think we're out of time. Sorry. So I think we're out of time for this week, so I just want to thank our speakers. I really enjoyed having a thematic topic this term, and I think having this wrap up where we think about where we should go next, I think is an important piece. And I thank you both for coming, and good luck with summer, everyone.
Thanks for the invite.